are the whole numbers and their negatives. So you must all know about whole numbers. You must have learned about these in your previous classes. So whole numbers are the numbers that starts from 0. So 0, 1, 2, 3, 4, 5, 6. These all are whole numbers, and whole numbers along with their negatives are called integers, and we can find all the integers on the number line, as you can see on your screen. Here on the left side of 0 we can see all the negative integers, and on the right side of the 0 on the number line we can see all the positive integers. All right, and we also need to know about the number line, the integers on the number line, that when we move to the left, we always the numbers always keeps on decreasing, and whenever we move on the right of the number line, the number always keep on increasing. All right, so now let's take an example. Can you write these marked integers in ascending order? All right, so for ascending order, we first must know that what's ascending order. So ascending order is arranging the numbers from smallest to largest. So as you can see, we have these numbers -5, -1 and 3. So as I already told you that whenever we move to the right, the number keeps on increasing. So that is why -5 is the smallest integer, and it follows by -1, which is the second smallest number, and 3 is the biggest of them all. So you can clearly see -5 is smaller than -1. So in the negative integers, this is the other way around. The number that seems bigger is actually smaller if we talk about the negative integers. All right, so we have learned about integers on the number line, how it works on the number line, and we have also learned how to arrange the integers in ascending order. Similarly, we can arrange our numbers in the descending order. So let's take an example of that as well. Okay, so we have the numbers, let's say 8, 9, -1 and -4, or you can say -4. Okay, so we need to arrange all these numbers into descending order. Okay, so what's descending order first of all? So descending order is just the opposite of ascending order. In ascending order, we arrange the numbers from smallest to largest, but this time we are going to arrange them from biggest to smallest. So first we need to figure out the biggest number. So if you see on the number line, after 7 there comes 8, then 9. So 9 is on the rightmost, so that is why 9 is the biggest. Then there comes 8, followed by -1, because -1 is bigger than -4. So this is how you can arrange all these numbers into descending order. All right, now let's take few of these examples. Here we can see some examples. Try these. So number 1 is a number line representing integers is given below. So all right, so here we can see a number line. In this we can see some alphabets, and we can see 2 integers. Okay, so -3 and -2 are marked by E and F respectively, which integers are marked by B, D, H, J, M and O. Okay, so they have marked 2 of the integers themselves, and we need to figure out what are these other alphabets representing which integers. So taking the reference of the numbers that are given, we can figure out that if this is -3, this is -2, then G must be -1 and H must be 0. So we have figured out H. Similarly, we can plot all the numbers here. So if this is 1, -1, 0, then there comes 1, 2, 3, 4, 5, 6, 7, and here as well we can count from here as well. This is -4, -5, -6, and -7. So B we can see is 4, 5, 6, that's -6. D is -4, H is 0, J is here 1, 2, that's 2, M is 5, O is 7. Okay, so we have figured out all the numbers. Now what do we have? The next question. Arrange 7, -5, 4, 0 and -4 in ascending order and then mark them on a number line to check your answer. Okay, so we have these numbers, that is 7, -5, 4 and 0, 0 and -4. So we need to arrange them in ascending order. So ascending order, again we can say ascending order is when we arrange the numbers in from smallest to largest. So first of all we need to figure out the smallest number. So you can check it from this number line. The -5 is on the leftmost on the number line. So that is why -5 is the smallest. -5. Then there comes -4, of course. Then there's -4 and then we can see there's 0. Then 4 and then 7. So we have arranged all of them in ascending order, where -5 is the smallest one and 7 is the biggest one. Alright, so now we have learned about integers and how to arrange them in ascending order and descending order using the number line. Now let's move on to the next slide and let's see what is there for us. Okay, so we have done addition and subtraction of integers in our previous classes. Read the following statements. So you must all have learned about adding and subtracting integers in your previous classes. So let's take a quick recall of those. So on a number line, when we add a positive integer, we move to the right. So whenever you will be adding a positive integer to any number, whether it is positive, negative or 0, you always move to the right on the number line. And when you add a negative integer, we always move to the left, and that is opposite. In case of negative integer, we always move to the left whenever we add any negative integer. Okay, and then when we subtract a positive integer, then it's the opposite from the first one. When we subtract, we always move to the left, and when we subtract a negative integer, we always move to the right. So we must always remember all these points while adding and subtracting integers. Alright, now let's take a few statements and let's figure out whether they are correct or not. So we will be reading the statements and then we will take some examples to figure out whether they are correct or not. So first, let's take the first statement. It says, when two positive integers are added, we get a positive integer. Okay, when we add two positive integers, so first we have to take some two positive integers. Let's say these are 4. 5 and 4. Okay, and they say when you will add these two, you will get a positive integer. Okay, let's figure that out. So let's say we need to add 4 to 5. We need to add 4 to 5. So for that, we know that when we add a positive integer, we always move to the right on the number line. So we need to add 4 to 5. So we have to take 4 jumps from 5 to figure out what will be the answer. 4 jumps to the right. So let's take 1, 2, 3, 4. Let's say there's 8 and 9 here. So we have reached 9. So when I have added 4 to 5, I got 9. So yeah, I have got a positive integer. So that means my statement, the first statement, is correct. You can take another example as well to figure out whether it is not an exception. So let's take 1 plus 2. So that, let's say we need to add 2 to 1. So again we are adding a positive integer and we have to move to the right. So let's take 2 jumps from here. From 1, let's take 2 jumps and we will reach to 3. So that means 1 plus 2 is equal 3, and again we got a positive integer. So that is why when you add two positive integers, you will always get a positive integer. So first statement is true, and you always need to remember this. Whenever you will add two positive integers, you are always going to get a positive integer. Now let's figure out the next one, which is when two negative integers are added, we get a positive integer. All right, let's figure that out. When two negative integers are added, we get a positive integer. Okay, so let's try adding let's say add -2 to it. Okay, so we are adding -2, we are adding -2 to -1. So here we have -1 and we need to add -2. So we know that when we add a negative integer, we move to the left. So you have to move to the left. So from -1, I am gonna take 2 jumps. So 1, 2, I have reached -3. So I got -3 here. So what have I got? Have I got a positive integer or a negative one? So clearly we can see we got a negative integer, that is -3. So that means the statement, the second one, is absolutely incorrect. So, and we can also see, as we know that on the left side of 0 there are all negative numbers. You are going to find there's no way that you can find a positive integer on this side, on the left side of the 0. You are always going to find a negative number only. So that's why this statement is incorrect, because if you take a negative number and add a negative number, you have to move to the left only, and in the left you will always get negative integers. So that means when two negative integers are added, we always get a negative integer, not a positive one. So second is complete. Now let's come to the third one. Third one says when a positive integer and a negative integer are added, we always get a negative integer. Okay, let's figure that out. When two different kind of integers, that is one positive and one negative, are added, we always get a negative number, they say. So let's figure that out. So let's say we add 3 to negative, let's say -4. We need to add 3 to -4. Okay, so I have got -4 and I need to take 3 jumps. Since I am adding a positive integer, I have to move to the right. So I'm gonna take 3 jumps from -4 to the right. So 1, 2, 3. I got -1. Okay, that's a negative integer. Alright, let's take one more example. This time I'm going to add 5 to it. Okay, so I have to take 5 jumps this time. So there's -4 and 1, 2, 3, 4, 5. I have got 1. That's a positive one. So I got negative as well as positive. So what does that mean? It means we can get either positive integer or we can get negative integer. Both are the possibilities. So that means this statement is not always true. It can be true sometimes but not always. We can either get positive one or a negative one when we add two different kind of integers. Alright, now let's take one more example of this. Let's add 4 this time. Let's add 4 to -4. So if I take 4 jumps from here, I will get 1, 2, 3, 4, and here I got 0. Okay, that's a different case. I got 0 this time. And let's take one more example of this kind when I add a positive and a negative integer of same number. Let's say 4 is same but they are opposite. One is positive and one is negative. So let's figure out this. This time I'm gonna add -3 to 3. So I have to take 3 jumps to the right from -3. So 1, 2, 3. Oh, this time again I got 0. Alright, so from this example, what I am trying to show is I am trying to tell you about additive inverse. So here you can see the additive inverse of any integer a is -a, and the additive inverse of -a is a. So as you say there's 4, its additive inverse is -4. So if you add a number to the first number and you get 0, that means it is its additive inverse. You have added 4 to -4 and you got 0, so that means 4 is the additive inverse of -4. Again, you have added 3 to -3, that means 3 is the additive inverse of -3, and vice versa. -3 is the additive inverse of 3. So for general, we can say that for negative for an integer a, -a is its additive inverse, and for -a is the additive inverse. Okay, so our fourth statement says additive inverse of an integer 8 is -8 and additive inverse of -8 is 8. Yes, for 8 it is -8. If you add -8 to 8, you will get 0. And again, if you add -8 to 8, you will again get 0. So that means this statement is true. Now let's come to the property of addition and subtraction of integers. Okay, so the first property is closure under addition. So we have learned that the sum of two whole numbers is again a whole number. For example, 17 plus 24 is equal 41, which is again a whole number. We know that this property is known as the closure property for addition of the whole numbers. So you must have learned about the closure property for the whole numbers So that says if you add two whole numbers, you will get a whole number again. If you add two whole numbers, you will get a whole number. So this property also applies to integers. If you add two integers, you will again get an integer. And that means integers are closed under addition. for any two integers a and b, a plus b is also an integer. Let's take few example of this. You add 17 and 23, which are two positive integers, and you get 40, and 40 again is an integer. If you add minus 10 and 3, you will get if you get minus 10 and 3, if you add both of them together, you will get minus 7. 7 again is an integer. Minus 7 is again an integer, a negative integer. Okay, if you add 27 to minus 27, you will get 0. 0 is again an integer. So that means if you add two integers, you are always going to get an integer. So that means the integers are closed under addition. They follow closure property of addition. So this one was the first property. Now let's come to the second property of integers, which is closure under subtraction. So what happens when we subtract an integer from another integer? We can say the difference is also an integer. Okay, let's figure that out. Okay, we take away we subtract 9 from 7, we get minus 2, and minus 2 is an integer. If you subtract negative 21 from 17, you will get 38, and 38 again is an integer. If you take away 0 if you subtract 0 from minus 29, you will get minus 29, which is again an integer. So again, if you take away an integer, or if you subtract an integer from an integer, you are always going to get an integer only. So that proves that integers are closed under subtraction as well. So they follow the closure property of subtraction as well. Subtraction and addition both. So I hope that is clear to all of you. Now let's move on to the commutative property, and let's figure about it. So we know that 3 plus 5 is equal 5 plus 3 is equal 8. 3 plus 5 is equal 5 plus 3. That is, the whole number can be added in any order. You can either say 3 plus 5, or you can say 5 plus 3. That doesn't make any difference. And this property, if you can add the whole numbers, if you can add any two numbers in any order, that means it follows the commutative property. In general, we can say a plus b is equal b plus a. That shows the commutative property. Okay, so let's figure out, is it same for the integer as well? Okay, so let's take this example. 5 plus minus 6 is equal minus 1, and minus 6 plus 5 is also equal minus 1. So they have added them in a different order. First they have added 5 plus minus 6, then they have added minus 6 plus 5, and it didn't change the answer. So that means they also follow the commutative property. You can also try some more examples and figure out yourself. If you add minus 8 and minus 9, you will get minus 17, and if you add minus 9 and minus 8, again you will get minus 17. So you can try some more examples to figure out whether it is correct or not. So we can say that addition is commutative for integers. Addition is commutative for integers. So it follows commutative property of addition. Okay, now we know that subtraction is not commutative for whole numbers. Is it commutative for integers as well? So we know that if you do 3 minus 5, and if you do 5 minus 3, that won't be same. If you do 3 minus 5, you will get minus 2, and if you do 5 minus 3, you will get 2. So both are different. So that means whole numbers does not fall, are not commutative under subtraction. And for integers, it is the same. If you take this example, let's take 5 and minus 3. Is 5 minus 3 the same as minus 3 minus 5? No, because 5 minus 3 is equal 5 plus 3, which is equal 8. And again, minus 3 minus 5 is equal minus 3 minus 5 is equal minus 8. So both have given a different answer. It has given 8 and it has given minus 8. So you can take some more examples of this kind and figure out yourself. And by this we can conclude that subtraction is not commutative for integers. Okay, all right. Now we have figured out that it follows closure property of addition, it follows closure property of subtraction. It is commutative for addition is commutative for integers, but subtraction is not commutative for integers. Addition is commutative for integers, but subtraction is not commutative for integers. All right, now let's move on to the next property, which is associative property. Okay, now observe the examples. Consider the integers minus 3, minus 2 and minus 5. Let's take these numbers and figure out and let's find out whether integers follow the associative property or not. Now look at minus 5 plus minus 3 plus minus 2. So this time they have put these two numbers under bracket, this operation under bracket, and in this one they have put minus 5 and minus 3 which are being added together in a bracket, and this is left alone. Okay, in the first sum, minus 3 and minus 2 are grouped together, and in second, minus 5 and minus 3 are grouped together. So we will check whether we get the different results. Okay, let's figure that out. So if you do this calculation, minus 5 plus minus 3 plus minus 2, you will get minus 10. And if you do this calculation, you will also get minus 10 in this case as well. Okay, that's great. So in both cases we get minus 10. That is minus 5 plus minus 3 plus minus 2 is equal minus 5 plus minus 2 plus minus 3. So it didn't make any difference whether you put these two together in a group or you put these two together in a group. It didn't make any difference. So that clearly shows addition is associative for integers. That means integers follow this property, that is associative property. And in generally we can show it by a plus b plus c put together in a bracket is equal a plus b in a bracket plus c. You can take some more examples. Here are some examples given. You can solve them, and okay, let us solve them together. So that is minus 3 plus 1. Okay, let me try a different bracket for that. 1 plus minus 7. Okay, let's try to do this one. All right, now If we solve this, we will get minus 3. First we will solve the big bracket. So 1 plus minus 7 gives us minus 6. Okay, and that will give us, if I add minus 3 to minus 6, I will get minus 9. Okay, now let's consider the second one, in which minus 3 and 1 are put together in a bracket. So from this I will get minus 3 plus 1 is equal minus 2, and I have minus 7 as well. Sorry, it again gives us minus 9. So both of these calculations have given us minus 9 as the answer. So that didn't make any difference. So we have figured out one more such example. So it proves that addition is associative for integers. Okay, and in general we can say, if we have three integers, a, b and c, a plus b plus c put together in a bracket is equal a plus b put together in a bracket plus c. So they follow associative property as well. Okay, now let's move on to the next slide and let's see what is there for us. Okay, there comes the additive identity. So we have figured out additive inverse. So additive inverse was, if we have this integer a, minus a is the additive inverse of a, because if we add these two together we get 0. So now let's learn about additive identity. When we add 0 to any whole number, we get the same whole number. If you add 0 to any whole number, if you add 0 to 1, you will get 1. If you add 0 to 100, you will get 100. If you add 0 to 1000, you will get 1000. So it doesn't change the whole number. If you add 0 to any whole number, you get the same whole number. So 0 is an additive identity for whole numbers. For whole numbers, what is their additive identity? It is 0. Is it an additive identity again for integers also? Okay, let's figure that out. Observe the following and fill in the blanks. So first one is minus 8 plus 0 is equal minus 8. Yes, if we add 0 to minus 8, we get minus 8. If we add 0 to minus 23, we will get minus 23 only. It doesn't change our number. Again, we have, if we add 0 to minus 59, we will get minus 59 only. Again, if you add 0 to minus, okay, so what should you add to minus 61 to get minus 61 only? So this time it will fill with 0, because 0 is that number that you add to any integer, you get the same integer back. So it clearly shows that 0 is the additive identity for integers also. 0 is the additive identity of integers also. The above examples show that 0 is an additive identity for integers. You can verify it by adding 0 to any other 5 integers. You can take any 5 integers of your choice, you can add them 0 to it, and you can figure out whether it is correct or not. So in general, for any integer a plus 0 is equal 0 is equal 0 plus a. So this is also an example of commutative property. They have added both of them in different orders and they get a only. So they have told you about additive identity as well as the commutative property. Okay, so 0 is the additive identity of integers as well. Okay, so we have learned about additive identity here in this slide. Now let's move on to the next one and let's see what is there for us. Okay, so now it is multiplication of integers. Multiplication of integers. We can add and subtract integers. We have learned about how to add and subtract integers. We know that we move to the right on the number line when we add any positive integer. We move on the left of the number line if we add any negative integer, and if we subtract any positive integer we move to the left, and if we subtract any negative integer we move to the right. Now it is time to learn about multiplication of integer. How does it work? So multiplication of a positive and a negative integer. First we will figure out how to multiply positive and a negative integer. Okay, so we know that multiplication of whole numbers is repeated addition. So we know about that. Yeah, if you have to do 5 times 3, you have to add 5 3 times. That is how you get 15. Now can you represent addition of integers in the same way? We know whole numbers are the multiplication of whole numbers are done in this format. It is being added it is being added it is being added whatever, like you need to times 3 by 5. You need to times 5 3 times, so you have to add it 3 times. So is it same for the integers as well? We need to figure that out. So in general, for any two positive integers a and b, we can say a times minus b is equal minus a times b is equal minus a times b. What does that mean? We thus find that multiplying a positive integer and a negative integers, we multiply them as whole numbers and put a minus sign before the product. We thus get a negative integer. So whenever you multiply two one positive and one negative integer, you always get a negative integer, because in this example you can see a times minus b is equal minus a times b. Whether you put this minus sign in front of b or in a, it doesn't make any difference in while you are multiplying these. Or you can keep it outside bracket and you can times both of them and put a negative sign before it. So if I take an example of it, let me take an example. If I am timesing 5 multiply minus 3, it is equal minus 5 multiply 3, or we can say it is equal minus 15. Okay, so now we must know that when the signs are opposite, whenever we are multiplying two integers, one is positive and one is negative, our product will always be negative. A times minus b is equal minus a times b. Okay, whatever two such integers you multiply, you will only get let's say minus 1 multiply 1, we always get minus 1. So whenever you multiply two different integers, that is one positive and one negative, the product will always be negative. You always need to remember that. Okay, now let's move on. to the next one. Now multiplication of two negative integers. Now how does this work? Multiplication of two negative integers. Can you find the product of minus 3 times minus 2? Observe the following. Minus 3 times 4 is equal minus 12. This is an example of what we have learned on the previous slide. This is a positive integer, this is a negative integer, and we are multiplying both of them together and we get a negative integer. Again, minus 3 multiplied 3 is equal minus 9, and what they have done here is they have subtracted minus 3 from minus 12, and again they have done minus 3 multiplied 2 is equal minus 6. Now they have subtracted minus 3 from minus 9. Now they are what they are doing is they are multiplying minus 3 by 4, 3, 2, 1, 0 like this, and for that they are subtracting the minus 3 from whatever we get in the previous one. Okay, so in this way they will come to minus 3 multiply minus 2 is equal 3, and then they again have subtracted minus 3 from it. This will give them 6. So what have you noticed here? They have got a positive integer. So that means, so observing these products, we can say that the product of two negative integers is a positive integer. Okay, we multiply the two negative integers as whole numbers and put the positive sign before the product. We can multiply the numbers that we have and we can put a positive sign in front of them. For example, this one, minus 10 multiply minus 12 is equal 120. And we have put a positive sign in front of that, and it doesn't make any difference if you write this or not. Plus 120 plus 120 is equal 120. So the thing here to notice is minus 10 multiply minus 12 is equal 120. So whenever you multiply two negative integers, you multiply two negative integers, you always get a positive integer. Okay, in general, for any two positive integers, a plus b minus a multiply minus b is equal a multiply b. So it clearly shows if you multiply two different integers, that is one positive and one negative, you will get a negative integer, and if you multiply same kind of integer, that is positive positive or negative negative, you will get a positive integer. So we can remember it this way. If you multiply plus and minus together, you will always get minus. If you multiply plus and plus together, you will get plus. If you multiply minus and minus together, you will get plus again. So you can remember it this way. If you multiply plus and minus together, you will get minus. If you multiply plus and plus together, you will get plus. If you multiply minus and minus together, you will get plus again. Okay, let's take an example. One more example. Minus 5 multiply minus 3 is equal minus 5 multiply 3, which is equal minus 15. Sorry, no. That will be positive. My bad. So that will be 15. Let's take one more example. Let's say we have minus 4 and here minus 2. It will be equal 4 multiply 2, and that will give you 8. So minus 4 multiply minus 2 is equal 8. Okay. Alright, so today we are going to learn till here only. In our next session, we will learn about properties of multiplication. Alright, till then, take care of yourself. Bye bye. Have a very good day.